So thank you for those joining the session. This is a joint session, joint meeting between the interest group RDM in engineering and the interest group metadata of RDA. Today we have a document where you can find the program of the session. You find the links to the presentations, and you also find there a table where you can add your name. Please, as attendees, Daniela, could you paste also the link in the chat so that it's easier for people to open it? So that is our reference document. There is also some instructions for the breakout sessions that we will have later on. So the program of today is now an introduction, short introduction. I will present a summary of an online seminar series we were running from July until the beginning of October. Then Alex will introduce the recommended metadata elements that we will be working on today. And we also have a colleague from Germany invited to talk about a new project that is starting, which is very exciting, also within metadata and engineering. And we will have some work in breakout rooms. And then we will come back and share our discussions from the breakout rooms, and then we will close up the session. For those joining, Daniela just pasted in the chat the link to the Google Doc that we will be using today, where you can find all the information. Very shortly on presenting for those that do not know the interest group of metadata. Alex, would you like to say a couple of words?
Yes, the metadata interest group is one of the longer running groups within RDA. So we started sort of back in 2013, and our first meeting was in the beginning of 2014. And over that time, we've been providing a forum for cross-domain discussions about metadata issues. We quickly sort of crystallized that into some specific actions that we wanted to do. And so they were expressed in a document that the metadata interest group led on, but it was a collaboration between that and some of the other generic metadata-based groups within RDA, metadata principles and their use, and you can look that up on the RDA website. One of the proposals at the end of that document was to define metadata packages which gave the metadata that would be required for several different defined use cases. And in order to be able to define that, we needed a metadata element set from which to build these packages. And so much of our work over the years following that has been on the recommended metadata element set, which I will be presenting on a bit later. But we also provided a oversight over a couple of working groups, the first of which was a metadata standards directory working group, and a few years later a follow-on group, the metadata standards catalog working group, which took the directory and changed it from a kind of static website into more of a dynamic online application. And I'll be again mentioning that in brief later on. We had our main interest group meeting yesterday in Breakout 3, and it was a very productive meeting where we managed to make some good progress on several of the elements within the metadata element set. And we've got another one scheduled for tomorrow, working with the social science community. But it's a real pleasure to be able to work with you today on the sort of engineering domain.
Thank you very much. Oh, sorry. Press on the link. Sorry, I will need to go back to here. All right, thank you very much. And a little bit on the interest group RDM in engineering. We were endorsed not so long ago, so last year in August, and our kickoff meeting was in October in Helsinki, in the RDA plenary in Helsinki. And since then, we established 4 focus groups that we have been working on different activities up to now. Those focus groups are engineering and open science, engineering specific DMP, and yesterday there was a BOF because there will be a working group on establishing discipline specific guidelines for data management plans. The third focus group is metadata for engineering, and we were running, as I said, an online seminar series. And the fourth topic is data annotation, which we kind of merge also with the metadata focus group. Our session, our interest group session is tomorrow at 5 Central Time. That means 6 o'clock in Central European Time is the breakout 7. So we would be happy to see you there as well. But we will also like to know a bit about you. So we will use Mentimeter, and you could use the first link indicated in the slide that Daniela just pasted in the chat. And there you should go directly to the Mentimeter presentation, or you can go to www.menti.com and enter the following code. And what we would like to know about you is, let me try to find the right here. So I hope everybody is in. The first question is, what is your role and function? Or function? We would like to know what our audience is. Excellent. Very nice mixture. We have another also. I think we are missing 2 people. I hope you could manage to go in for the next questions. I will move forward. From which country are you joining us today? Nice. So we have people from across the ocean. Nice. Very good. More people are joining. All right. And the last but very important question. How are you feeling before we start? Excellent. Oh no, sleepy. Get some coffee. Grab some coffee in the first minute. We need your brains today for the activities. All right, I think we are on a good way for a good productive work. People are curious and excited to know what we will be doing today. So I think I need to stop sharing again and sharing again. Or, sorry. All right. So I will start telling you a little bit about what the interest group RDM in engineering has been doing. We ran an online seminar series from July until the beginning of October, and the series was called Exploring Annotations and Metadata Initiatives for Engineering Data. This was an idea that came up because talking to different colleagues from different interest groups and at RDA and from our meeting in Helsinki, we discovered that there are lots of things going on regarding metadata, metadata standards, data annotation. And we were wondering if there is some effort, if there were some efforts in the engineering discipline. So we look and so the idea was to explore together with the engineering communities, what are the challenges, how to solve them, what initiatives are there that maybe are already solving some challenges, and also to know where are the gaps regarding metadata for the engineering disciplines. We had 5 online seminars and we had a total of 11 speakers. As you see, it was a very crowded agenda. We started with a joint seminar with the interest group on preservation tools, technologies, and policies, the PTTP. Then we move more into the metadata and also metadata tools, meaning tools or software that are under development to embed or create metadata within different engineering disciplines. We had one session with the interest group in small unmanned aircraft systems. Um, we also had invited researchers that are actively working on creating metadata standards, but also establishing workflows. We also learn about some infrastructure that is already there and some tools that are provided that helps researchers to create templates and that are very adaptable to engineering. And we also finish up with 2 more initiatives regarding research communities metadata standards. Is a European project on low carbon energy. And also there we had Alex presenting this metadata element set. And then it came the idea to have this joint session together and work a little bit more on that. All the presentations and recordings are in the repository of the interest group. So I invite you to go there to explore what we did. And only some small short reflections. We could see that there are some metadata standards for engineering already there, but apparently the communities do not know about it. So one of the questions that came up is how do we make those standards more visible so that we avoid duplication of work, for example? How do we engage with other members of those engineering communities so the standards are adopted or updated or adapted if needed? And also there is still, although there are some tools there, I think most of the people recognize that there is a gap that once you have selected your metadata standard for your research, how do I easily implement these metadata standards into when I'm collecting, acquiring the data sets? So do I need to wait until the last minute when I want to publish my data? Or it would be good, and researchers want to do this during the active research process. So I think there is still a lot to explore there, and there is still a lot to do there. So hopefully in the future, we could help a little bit in that direction. So what we would like to do next, we asked the people in the seminars what they would like to have, which activities they would like to have around metadata. And there were 2 options of what it was offered that were more preferred. One is to continue with actually the seminar series. I think people is curious to know what is there out there that they could use, that they can adapt for their own needs. And also to create use cases on if there is a tool there how researchers are using it. So to create use cases of workflow, how researchers within engineering are embedding metadata to their data sets while they are doing their research, if there are those cases. So what we would like to start, well, the online seminars will continue from January on. We already have some ideas to who invite next to present. But most importantly, if you know, if you are a researcher and you have a good workflow for embedding metadata into your data sets during the active research process, or if you are RDM support and you know that at your institution there is a group advancing in this direction, please contact me to talk to them, and we will see how we can create these use cases. And of course, if you would like to work on this together with us, creating those use cases, also please contact me. We always need hands for help to doing this. I saw that Rainer, you raised your hand. Would you like to comment something?
Yes, just a small comment from the RDA side. In RDA, we don't have it implemented properly yet, but we are collecting use cases from all working in interest groups. There is a virtual group, there exists a virtual group which is called use cases. You will find the link easily by Googling RDA and use cases. And if you want to contribute your use cases to that list by a link or so, just send me an email and I will be happy to include your use cases into the list.
Okay, great.
Because many groups in RDA are collecting use cases, and maybe some of them, these are use cases, can be reused.
Yeah.
That's the idea behind that.
Excellent. I will contact you. And if we have interesting use cases, of course, we will be happy to incorporate them to what is happening already. All right. So that was from my side. I think that was my last slide. So now is the turn of Alex. You will presenting the work of the interest group metadata.
Okay. So, hello. Yes, my name is Alex Bull, and I'm a research data librarian at the University of Bath, but I'm speaking today on behalf of the metadata interest group. So over the course of the next 10 minutes, I'll be introducing our recommended metadata element set, which has been the main focus of our activity over the past few years. So apologies in advance if you've seen much of what I'm about to say before, perhaps even yesterday if you're in our meeting then, but even so, I hope you'll find it useful to go over these things. But before we get into the details, I want to be clear about what the metadata element set is and what it's for. So it's not intended to be a new metadata standard in its own right, but it's intended more as a tool with both a prescriptive and a descriptive role. The prescriptive role isn't that prescriptive, but it's meant as a starting point for anyone who is trying to, or any group that is trying to develop a new domain metadata standard. So it is providing, maybe you could think of it as a checklist of important elements to include, and it will give some advice on good practice in metadata modeling. So we've got some advice on the kinds of identifiers, for example, that you should use for a data set. We have advice on which elements should be thought of as properties of an entity and which should be thought of as relationships between entities. The descriptive role is as a tool for analyzing existing metadata schemes. So you can analyze them to see where particular pieces of information occur, how they've been implemented within a metadata scheme. You might be familiar with the notion that RDF provides this kind of facility for say for relating the elements that you're using in a particular scheme to a more well-known metadata scheme, you can inherit it. You can say that it is a special case of, or is the same as an element in a different scheme, but not all standards are defined using RDF. So this is providing a kind of standoff annotation method for being able to express that same idea, but across any arbitrary metadata standard. And so as a consequence, we'll be able to use the metadata element set as a kind of Rosetta Stone for interconverting between arbitrary standards. And I'm fond of this metaphor of the Rosetta Stone, because as you can see from the illustration on the slide, the Rosetta Stone itself was not a complete solution, and neither is our metadata element set, but we think it's going to be a good starting point. So in order for this to work in a scalable way, we're going to need a repository to store these analyses in machine actionable form. So the plan is to start collecting them in the metadata standards catalog that's been developed by the RDA working group of the same name. The catalog currently links out to existing crosswalks that have been designed by metadata experts. But what we intend to have in addition to that are these analyses of the native specifications for each standard, so that we could then offer a service to match up similar elements into arbitrary schemes and do some basic mapping between the values expected by one and the values expected by the other. And that will give us the basis for a rough and ready converter between those two standards, which may be good enough by itself for some purposes, but for others will at least give a good starting point for a more polished converter that's finished off by a human. So how far have we got with this? A few years ago now, the Data in Context interest group led an effort to collect a lot of metadata use cases. And the metadata interest group analyzed the elements that came up in those metadata use cases. And we extracted from them some of the metadata elements that kept recurring across many of the different ones. And you can find the full analysis spreadsheet and some explanatory slides from the link on the slide. And ever since we've done that, we've been debating the metadata element set at the RDA plenary meetings. And we are now in this process of trying to unpack the elements and give some greater detail within them, because they are at a fairly high level. So if you were one of the people who said you were feeling sleepy, now is a great time to grab that mug of coffee, because I am going to go through these. They're important for what we're going to be doing later, so strap in. To begin with, unique identifier. A data set may have several of these. They might be a different identifier according to different schemes. They might have different identifiers satisfying different use cases. They might have a different identifier for different versions or for different subsets of the data. Under description, we're grouping together all sorts of free text descriptions of the data set. So not only what you might think of as the abstract of the data set, but also the title, a description of the methodology used to create the data set, free text aids for navigating around the data set, and well, anything aimed at a human reader to help them understand it. Under keywords, we're using that to group together any elements whose values are terms, words, phrases, concepts that describe the data set or an aspect of it. They might be chosen freely, or they might be for preference drawn from a controlled vocabulary. Spatial and temporal coordinates are intended to cover all aspects of spatiotemporal coverage, where and when observations were made or what was being observed. So that's not only the coordinates themselves, but the coordinate system that's being used, their accuracy, and the precision, and the resolution of the data. By location here, we're meaning addresses that can be used for accessing the data set. So whether that's for download or a site where you can perform a dynamic query on a database, or a form for requesting dataset from a dissemination access system. So for a network resource, this will normally be a URL, but it might possibly be a physical address if the data resource is analog or kept offline due to its size or whatever. Medium and format is more or less what it says on the tin. Availability, we're talking here about access arrangements, restrictions and conditions and costs, but we're also including within that things on the usage end, so licensing and other usage restrictions and conditions. And one of the things we put under this banner in the early analysis was retention policy, so the policy for how long this would be made available. Under schema, that's elements that describe how the data set has been arranged and encoded. So that might be talking about XML schemas and database schemas, but it's also broader than that. So it would also include things like code books for how values have been encoded and details of controlled and measured variables. The quality is fairly straightforwardly how a resource performs against relevant quality metrics. Under provenance, I think we probably had a narrower idea of provenance there than what you might normally think. So thinking about the version history or processing history of the data set. Under originator, that's considerably wider than it sounds. So that includes any individual or corporate data creators, contributors, distributors, publishers, contacts, right holders, and other agents with a stake in the data set. Project is covering project codes, funders, reporting year, all those kinds of things. Related publications and software. So these are resources that are related to the data set in a way that's specified by a role. And when we're talking about software here, again, it's a fairly broad conception. So it's any kind of code that might, that could be algorithms, scripts, libraries, or full applications. Under citations, we're currently including two distinct concepts there. One is information on how to cite the current resource, and the other thing is lists of references to the dataset made by other resources, although we had some discussion about whether that was appropriate yesterday. Under facility and equipment, so that that is the facilities and equipment that have been used to generate the data set and when they were used. So there are some overlaps and interrelationships between these elements that we need to deal with. I think particularly around, as I was saying, the citations and related publications, and also thinking about the relationship between provenance, temporal coordinates, and most of the elements on the right-hand side. So we've got a lot of work to do here to unpack these elements and pin down the semantics and syntax that we want them to have. For a long time, I think it felt like we were staring at a blank page, wondering where to begin. So in May this year, we put out a survey asking people what they considered to be the highest priority elements that we should be tackling first. And over the course of about 2 months, we received 37 responses, and we got a clear message that the unique identifier element was the most important one for us to look at. It was ranked first by about 80% of respondents, followed by description and location. But that was 37 is quite a small sample considering the number of researchers that there are in the world. So for the purposes of our meeting today, I had a look at the survey that was conducted in relation to the Mgmt effort, and comparing the results of that survey against our element set. I think I would rank our elements in a different order, so the ones on this slide. So in our breakout sessions a bit later on, I'd like to for us to discuss, I think, maybe the first 6 of the elements on this slide. But before we get to that, we do have, I think, a little bit of time for questions. So I'll leave up the link to the Google Drive folder where we keep the documents that we're using to work on the element set. But I'd like to invite you now to share your thoughts and any questions that you have on what I've just said.
Yes, we had a question already in the chat from Gretchen, because you talk about interconverting, and she's wondering, is interconverting what we often refer to a crosswalk?
Yes.
As a crosswalk?
Yes, so it's about if you've got metadata according to one scheme and you need it to be converted into a different scheme, then yeah, the process from getting from one to the other. So that would normally be a crosswalk. So obviously there are a scalability issue of being able to write converters, custom converters between every conceivable pair of metadata standards. And so what we want to do is to cut down that complexity. So instead of a n squared converters, we only have to write n, so they're all going via this metadata element set.
All right. We are not that many in the session, so Gretchen, I think you added a question in the chat again. Would you like to open your mic and just share with us the question?
Yeah, thanks, Paula. So yeah, since there was a small number, I took advantage of question bandwidth.
That's good.
So when you do the interconversion between different metadata representations, I was just curious, are you using specific algorithms to do the comparisons and the mapping, or is that something you're proposing that will be developed?
It's a proposal that will be developed. We need to get these elements sorted out first before we can think about any kind of automation of it. But yeah, in due course, the idea is that there will be a function in the metadata standards catalog that will be able to use the mappings to the metadata element set to be able to then connect up two different ones to do the matching and the mapping.
Yeah, I do know somebody that's has some methodology for doing this type of thing, and it's kind of in its early stages of development, but I'll mention this to him, Stuart Chalk, and he may be interested in that stage of the work.
Yeah, that would be really good. It would be nice to have some help with it.
Yeah.
Yes.
Great. We have a raised hand, Mark. Go ahead.
Yeah, thank you. I'm not entirely sure I understand this idea of these elements. Are these just single fields or terms which one value, which, right, I guess not, because if you have something like provenance, that's quite complex information, so there needs to be some kind of substructure.
Oh yes, very definitely. These are intended as high-level elements. They're not fields, and so we are expecting them to be broken down. And this is the process of unpacking. This is exactly what we're doing now, is to work out what sub-elements need to be within it, the structure that we need, what elements, what attributes we're going to need in order to capture the information that we need.
Okay, thanks.
All right. I think we should move to the next presentation. Then we can ask more questions, Alex, later on. Our next speaker is Matthias Grönewald, and he will talk about a platform for creating and sharing metadata standards and their integration into scientific workflows in mechanical engineering and related disciplines. This is a new project. I think they started very recently, and they wanted to share with us to engage with the RDA community on early stages. Matthias, you can share your screen.
Yes, thank you. Can I share the screen?
Yeah, You should be able to. Or,
Okay, let me. So,
yes.
does it look good to you?
Yeah, we can see it perfectly.
Great. Okay, yes, thank you, Paula, for the introduction. That's exactly what I want to talk about today. So, my name is Matthias Grödewald. I'm from the University of Darmstadt, and I want to talk about our upcoming project AIMS, or our recently started project AIMS. So AIMS short for Applying Interoperable Metadata Standards. And before I dug deeper into the actual project, I want to stretch this as a very cooperative effort. So our team consists actually of information scientists and engineers and IT professionals. So I myself, as I said, is a member of the State Library, University and State Library, which belongs to the University of Applied Science in Darmstadt. But we include members from the Aachen University IT Center, and also we have two engineering groups involved, the Chair of Fluid Systems at University of Applied Science Darmstadt, as well as the Laboratory for Machine Tools and Production Engineering at Aachen University. So overall, it's 4 partnering institutions from 2 universities. So in the beginning, I want to share our vision for AIMS in a way. So we want to create an environment for metadata standards to grow. And to build this, we combine a theoretical metadata model, an infrastructure approach to use cases application for our idea, and multiple partners gather to disseminate our platform. So the metadata model, which is one of the major cores of our project, we use is a concept of application profiles, metadata schemata built in a modular fashion from controlled vocabularies. And the resulting application profiles are then hierarchical, specific, and reusable. And they are separated into realms, but build a flexible reference network that supports versioning. So these major aspects, I will show a bit more detail now. So when we talk about our application projects, profiles being built from controlled vocabularies, we think of them as users of the AIMS platform being able to pick terms from curated lists, and in that way create different profiles to describe their application. In this way, for example, some sort of measurement. So, and these application profiles but are also hierarchical, which is a major aspect, as we plan them to being able to create children and parent structures. So children inherit all properties from their parents, but are, for example, in this case, there's a feature added as their child is more specific. As you see, application profile B is an application profile A, but has a detail added to it. So not only by inheritance, but in general, application profiles are modular. So building blocks, but still sorted into realms. So these modules are separated in a way, for example, as in method or object of research tools or similar. So these modules can then be referenced by other application profiles. For example, application profile could have another application profile as method, as shown on the top field, like has method, or could have an application profile in as value for a user's tool or something similar. So as you see, we are also thinking of these references as being qualified. So application profiles can be referenced in other application profiles. So together, these properties build a network, a reference network of application profiles. So application profiles are you can see, are structured in realms. They are but they stay modular. So our building blocks in a flexible manner to create new application profiles. They are hierarchical, so they inherit properties from their top elements, and this gives them a certain ability to be very specific to applications itself, to describe very specific features of data. And in the same page, they stay very reusable, as they are still modular building blocks for the actual system. So these are core elements. And so to realize this, we want to provide an infrastructure that allows users and researchers to apply this system. And our infrastructure is mainly consisting of a generator, an application profile repository, and a research metadata repository. So these are the three core columns in a way. So the generator, or I say generator UI, as it is in a way also the way we see for researchers or users to access the repository, should be used to create or reuse application profiles. So users can use it to build application profiles from the controlled vocabulary, or by modifying already existing ones to fit their actual application, and then store it in our application profile repository. The second basic process we are involving our infrastructure in is that creating devices or researchers basically are able to link to application profiles in the repository and upload their metadata in a validated way, in an application profile validated form to our research metadata repository. So for the application in our use cases, we plan on also providing, or in the course of the project for our use cases, also the vocabularies as the libraries with the implementing of the connection between the databases and the research devices are part of the project. So we integrate this into the workflow of our use case applications. So to give you an idea of our use cases, here are two examples of the research data we plan to describe. So this is a testbed at the Fluid Systems at the University of Applied Science in Darmstadt. It consists of many research data generating devices with quite rich metadata sets actually, which we plan to incorporate. And another example is this more virtual setup, which combines data on a totally different scale. So with multiple test beds and devices at the WZL in Aachen. As you see, these two use cases are from quite different fields of engineering and offer both multiple and diverse testbeds as application for our AIMS platform. So, and with this, I already want to give you an outlook, as this project is still in an early phase. So our current work focuses on establishing of the application profile representation and developing of repository infrastructure and the generator UI infrastructure, the actual coding basically, and also gathering entities to be modeled for our use case metadata as first application. And in the upcoming, hopefully near future, we plan on a pilot phase for the generator UA with a metadata standard repository as backend, and to gather information about the first workflow and establish a new workflow for the application profile generation for use cases. And also we hope for a first evaluation and feedback from the expert community, which you are hopefully a part of. With this, I want to close my talk, and I thank you for your attention. I'm open for question. I hope you're interested. Thank you.
Thank you, Matthias. Very interesting plans, I think. What are your questions for Matthias? You can open your mic, raise your hand, write it in the chat. Rainer.
I'm sorry. Actually, I have one question and a remark, and I will separate them both, so don't be afraid. If I'm looking into the definition of standard, listening to Alex and listening to Ames, I think you use a kind of a different definition of standard. Could you please elaborate on that?
Yes. I mean, in general, standard means like a universally applied way, and we kind of expect of a standard to be used by everyone in the field, and also to be standardized, so by some sort of institution defined in a way. So, but with metadata standards, we have seen there are multiple ones, and not all of them are uniquely. So our goal is to have a system that's flexible and a model that's able to be applied for many different fields. So as engineering is quite heterogeneous, we expect it to be quite a complex task to build one schema for them all, or build one standard.
Matthias, we can't hear you anymore. Maybe you can switch off your camera.
Yes.
Maybe I jump in. I'm also from the project Ames. I think the way we used standard in Matthias' presentation was just as a reusable description set. So it's not standardized in the case that has any official stamp being standardized by that and that organization, but it's a profile, a set that can be reused to describe something, and by being reused, it becomes standardized.
So a kind of a schema.
Yes.
Can you hear me? So yes, a schema, a generalized schema, or a way to build schemata. So our platform should enable users to build this schema for more or less any application, but still stay specific.
Just a second remark. In RDA, we had a couple of working groups working on the data type registry. There exists a full specification and a full implementation of that. And what you're talking, when you're talking about a kind of a profile repository, it really looks very, very similar from the specification of the data type registry. In Germany, for example, we have one of the data type registries running at the Gesellschaft für wissenschaftliche Datenverarbeitung, GWGD. Ulrich Schwartmann is running one of these. You might test this one because it is really great for storing and for providing profiles to the outside as a kind of a data type.
Yes, I think I'm not sure I'm 100% aware of exactly this project, but we are aware of similar ones. And of course, we hope to connect. So Ames is in a way a community effort. I couldn't elaborate too far on it as time was limited, but of course, our infrastructure is a bit more complex than I showed in these 3 columns now. And a major part of our as well of both the repositories basically is that they are built to be mindful of other existing ones and being able to interconnect via RESTful APIs or similar. So we hope to include as many of already existing works and schemas as possible and to extend them in a way.
So in that sense, it could be a possibility, for example, if the work of the IG metadata defining this set of elements, that this could also be used as one type of module to pick from? Because I'm thinking there are already a lot of metadata standards there where you have different metadata fields that you can choose from. subfields or syntax or
Yes,
so
basically.
where will you start from those that are already there, or you will create another one?
No, actually, we don't want to build another standard because it's a bit, perhaps you noticed it's kind of hard to build an actual example for our system. So we model very abstract actually. So the actual generator, for example, I named it, it works on a very abstract basic. It only more or less uses RDF, and it is a simple system to enter structured metadata into the repository and to validate it in a way. So how the elements are actually defined or which elements are entered, we don't decide on that. And our only premises on this is that we want our basic vocabulary, so the terms from which the standards or schemas are built, to be controlled. So for example, that's probably a difference to some of the other approaches that we think it's a good idea that those are defined lists for users to pick from, instead of just having free text and like everyone having to enter what they want. And then those elements are logically connected via qualified references. So that's about it. And this structure can then build more or less every schema you can think of.
Okay. All right.
I mean,
Good.
to kind of distinguish aims from the existing schemata or standards is that we really aim for the specific end of the description. So really the researchers, engineers are supposed to describe their specific one time in the world unique application for which there will definitely be no schema available. And for them, they have this generator to build their own schema, which is reusable in their group, and it has inheritance, so it will always, or it's supposed to have common ancestors via which it is interoperable with other schemas. And one of such common ancestors could be existing standards, of course.
Okay. Thank you. Are there more questions for Matthias or Mark? It's not the case, I think. But we are on time now then to do our work. This is also a session where we want to work. Alex, would you like to describe what we would like to do? And I have a question for you. We are 15 people in the audience. Would you still like to do breakout rooms, or shall we discuss in plenum?
I think with the number of participants we have, I think we could just do it all, as you say, in plenum.
Okay.
That will be fine.
So
Right.
if you share your slides to tell us what you would like to discuss, I will paste in the chat a link to another document that it was supposed to be one of the breakout rooms where we can take notes.
Yeah.
I need to...
Let me...
It's probably in the shared doc with the meeting notes. There's an instruction slide pointer.
Yeah. Do you need the instruction slide? Ah, there it is. And
So
I pasted
there
in the chat a Google Doc where we could take notes. I offer myself to take notes. So if you drive the discussion, Alex.
Okay. So what we'd like to do in this session is to have a look at these specifically these elements, which were the first 6 on the list that I showed you on my last slide, and to think about the kinds of information that we need to capture under each of them to suit sort of engineering domain use cases. So what we've set up some Google Docs for us to do this in, and so it'll be good if we could go through maybe each of these in turn and think about the kinds of things that we need to capture. And towards the end, then also have in mind any gaps, things that are really important to record in metadata for engineering research that would not be captured by the metadata elements as I described them to you in my presentation. And yes, so we then need to record those so we in the metadata interest group can have a look at them and see whether or not we can find a way of including them. So is that clear?
Is it clear for everybody? So maybe you can show on your screen, you have there, I think the document for the breakout room.
Yeah.
Is that one, I think?
Yeah, and the thing is going to pop down
Yeah,
from the top to
here.
stop you from clicking on it, but there we are.
Yes. So we have basically high-level elements, and you have a link to the definition that the interest group gave to what is meant with schema, and then we would like to discuss, according to that definition, what are the sub-elements or attributes. I understood correctly?
Yeah, so yeah, we're looking at, we're trying to unpack the semantics and ideally the syntax as well. But yeah, we're thinking about the kinds of information that we need to capture, what the kind of sub-elements and sub-elements within the high-level ones we're going to need.
So, Alex, this is Gretchen. Maybe if you can give a little bit of context for the high-level element that you're thinking about, and you know, schema. Just starting with schema, you're describing something that is in and of itself like a data set. But if you were going to adopt a particular schema standard, for lack of a better term, you know, just throw something out there like schema.org. Is that where you would put something like this, or is that not?
No, schema.org is a metadata standard that we might want to describe using this. So what we're looking at here, it's not a schema for a metadata standard, it is the schema for the data itself. Mm-hmm. So for example, the Open Knowledge Foundation came up with these sort of data package schema, and then with it as a sub-scheme within that, they have a tabular data package, and that provides some elements for describing the data model of a CSV table. So that then that's machine understandable and can be interpreted directly by scripts. So we're looking at you know, so what we're doing here is being able to capture that similar kind of information. So the kinds of things that we're thinking of including here are sort of elements that would be describing the parameters that are within you know, a particular column or a particular row in a data set. But, you know,
So like a dictionary?
Yes.
Dictionary? Would
Data
that
dictionaries would fall under this.
I'm sorry, I'm still a bit confused. Maybe Alex, I might give an example. If I look into schema, so let's say a schema has a unique ID, for example, a PID.
Yes.
A schema has a link to a human readable description. Is it what you meant?
Yes, I mean it's those okay. Kinds of things. Yes.
Thanks.
I don't know if it would be if I go down to description. I did do a sort of a straw man unpacking of this, and it might help to give some idea of the kind of things that we're looking for. So under description, I sort of spelt out the kind of semantics that we're trying to capture with this element. So as it's a portion of free text that in some sense describes the resource, but there are sort of subtypes within that kind of role or an aspect. So is this description acting as a title? And then maybe sub-elements below that. So it might be main title, alternative title, subtitle, and we've got abstract. Methodology, again, there might be subtypes of methodology, so methodology used to collect, methodology used to prepare existing data, method used to process data, methods used to prepare data for publication. There are some metadata schemes that have a free text field for describing the contents of a data set, which might cover the same ground as a machine readable piece of packaging information. There are some that provide fields for describing technical information. And so these are the kinds of semantics that we want to capture under the description element. When thinking about how to represent this sort of syntactically, we're thinking about the kind of properties that we'd need to discuss in order to be able to perform that mapping and matching. So things that we're going to need to know is it's free text, so we need to know what language it's written in, and it might be written in a particular dialect of a language. And so I've given a suggestion for there of how we might have a kind of controlled way of expressing that. The types and subtypes, and it might also be useful to know if there are particular formatting conventions that have been used within that field. So it might be just plain text, or it might be structured and marked up using something formal like HTML5, or it might be something a little less formal like Markdown or restructured text. And the kind of proof of the exercise then is to then see if we can actually use this to represent the information that is held in metadata schemes. So I took two here, and looking at the elements that are in these schemes and then describing them in terms of the metadata element set. So we've got ways of describing the titles and the various types of description that are in data site, and in Dublin core there are the title and alternative of both titles, and we've got description, abstract, table of contents. So that is the kind of thing that we want to get out of this. I mean, do you want to start with description then, and think about is there anything else that is missing from that needs to be added?
What about annotation?
Right.
Mm-hmm.
So so these annotations within the metadata that are describing particular granules of data within the data set?
Yes, that would be what I...
Yeah. So that's certainly something we can add in. Thank you.
Mm-hmm.
And you would like us to think about this in relation to engineering disciplines, or in general what we think?
If you have some general thoughts, then they would of course be welcome. I noticed we only had a handful of people who would self-identify as engineers in the group, but yeah, obviously
we have one engineer. All right.
Matthias, did you want to say something?
Yes, something I've seen similar list yesterday. I think I was already thinking about the spatial coordinates. I'm probably it's like trivial, but what I miss is like if it's absolute or relative coordinates. So I feel that's like the most basic definition of where to give how to describe a location or a spatial coordination, because a lot of if you're looking at a restricted space, often stuff is only located relative to something else.
Yep.
Mm-hmm.
So yeah, the coordinate system is certainly something that we need to have in here, because to think about this more generally, there'll be some domains that are thinking in terms of Earth-based coordinate systems, but then if we're trying to serve the needs of astronomers as well, they'll be talking more about galactic coordinates and things. So
and I'm thinking about the totally the bottom-up approach about people describing their lab. So I mean, that's metadata as well. And if you have 3 kinds of the same ovens, and you're an engineer, like, for example, we have I'm working with material scientists, and they have like different ovens, and all of them are the same model, but they're slightly different. So for them, it's important that it's 1, 2, or 3. And they just refer to them as the left one or the right one or the middle one. So something like this, if you like try to take notes or research data, you have to field for this.
Right, yes.
In that case, you might perhaps want to assign some identifiers to those ovens.
That's probably the gold standard, but they all have serial numbers, but we're still in the process of applying metadata to engineering.
But within your lab, they would be 1, 2, or 3, or ABC, or whatever.
Technically right, but there's movable equipment as well that gets rearranged. Think of reset up lab test beds.
Mm-hmm. Mm-hmm.
So I think we have a relationship that we need to think about between the kind of spatial coordinates being used to position pieces of equipment, and we have a separate metadata element for describing equipment. So we need to maybe think about the spatial aspects of that.
You may also have like a relationship to description. And what if you have a descriptive spatial region?
Well, yes. Now,
Northeast corridor or something. I mean, maybe that's a region observed, but it's a little more.
Yes. So this is where we have to be quite careful with the the wording of the semantics. I would think this would be something that would actually we want under spatial coordinates, but we're now talking about
like geographic. Yeah. There's geographical, but there's also like some colloquial. I have trouble saying that word. Terminology, right?
Yes. So there are metadata schemes that have elements that provide free text geographical coverage, but then there are others that might specify a controlled vocabulary for that, so they're geonames.
Like intercontinental and things like that, that are more like qualified spatial. It's not so much spatial coordinates, it's really spatial metadata, but so when you say, like with the metadata term, maybe rather than saying spatial coordinates, you could just say spatial, right? And then one of the sub-elements is coordinates, but spatial has a lot of dimensionality to it, right?
Yeah, I mean, we are, yes, the names that we've given these high-level elements, as you will have sensed from the talk that I gave, are the source of some degree of frustration that we've ended up with the ones that we have, and they don't always accurately reflect the kinds of things that we actually intend for them. So
you could, so this is just to expand a little bit on it. Like if you talk about spatial, you could then have like as sub-elements, you could have geographical, observed, coordinate, coordinate systems. They would become then your spatial sub-elements.
well, I think don't feel constrained by the top level label. If these things are to do with spatial coverage, let's get them down on that document.
Right.
And
Coverage instead of coordinates. Coverage,
yes,
maybe would be my recommendation. Spatial coverage, and then coordinates means something
yeah,
a little different than coverage. And in astronomy, that was my background. We actually went to coverage. Same with temporal. We went to using that term to give that kind of flexibility. So just an idea to throw out there.
yes. And yeah, I mean, when we're talking about astronomy, then things do get a little bit complicated as the relationship between the spatial and the temporal, because obviously the further away the object is, the further back in time it is. And so that there is, the two things are not independent.
If you have a data set describing measurements of some effects happening on a keel of a ship, and the ship is traveling, would it fit in the spatial coverage as well?
I was also thinking the same thinking, for example, with the drones that are now also used to gather data. If you have a flight trajectory, would that also fit in spatial coordinates?
Well, I mean, it is to do with where the thing is, so I would say it does. Yes, in oceanographic things, you have your cruise,
orbital. Yeah.
And that means you might have several independent, say, elements within there. You might have the flight path of your drone, and then you might have some observation, which is in the relative location of the drone at that particular moment.
In a specific coordinate and time stamp or something.
So you might have a moving coordinate system from the point of view of the drone.
You can have field of view. Field of view is, so you would have a certain region and then a field of view resolution.
We don't have a lot of time left, but I was wondering, I have a question about provenance. Is that very different depending on the type of experiments you are running? Can you really, I mean, besides author and I don't know, organization, or is it possible to find granular elements that fit more than one experiment type, for example?
Well, as I've put in the scope notes there, when you're talking about things like the version history of a data set, or you might be thinking about how a kind of dynamic data resource has evolved over time. These are things that would be captured under provenance. And that isn't particularly domain specific. It's more, how a particular data resource has been arranged. But then, you can go into more detail as to exactly who did what to it when. There are, I mean, there is the Prov W3 model.
I have to put a plug in for our breakout tomorrow. I'm presenting on provenance.
Yeah,
There we go.
that's why I also asked to do the link with that, because I think it would be interesting maybe to continue collaborating in that particular field, right, Gretchen? So
Yes,
if we discover
would.
something,
it would.
maybe we could contribute to the discussion to that term.
Yeah.
Which I'm very curious tomorrow to know what will happen in the session.
Yes. Yes.
Yeah.
Yes.
Yeah.
As I say, the provenance interest group was involved in some of the original use cases that fed into this work.
Are there
So,
more
yeah,
questions for Alex about other terms maybe that you want to contribute to? I was also looking at related software, and what happened when the researchers create their own code, for example, to just analyze certain type of data? It's not a software package, probably. It's just a bunch of scripts. Would you include that also into related software? Which is, I don't know, they create some Python code. I don't know.
I would say certainly.
Yes.
It's important. And ideally, you would push those scripts maybe on some GitHub page, and then you would have some identifier from there.
A link to the, okay. Yeah.
I would say type, related software, some kind of typing as to whether it's like build software, application software, services, yeah. So some kind
differentiate between different software types or something.
Yeah, open source.
Yeah, proprietary. Yeah.
Can be
licensing.
It can be actually two types of relations. It can be software that was used in producing a data set.
Yes.
Or it could be software that is meant to consume the data set, to analyze it further, perhaps.
Yeah.
And the former case perhaps has to do with provenance, because the software that was used to produce this data set does indeed have an effect on how the data set came to be.
And then related to software, you might want to, so there's a software source code identification interest group, and they came up with some PID schema for identifying software.
Yes.
I don't know exactly what to pack it, but as far as I know, especially for the engineering community, licenses are very important.
Can you speak a bit louder? I didn't hear, sorry.
Oh, am I? Okay. Especially for the engineering community, licenses are very important. Yeah. I don't know exactly where to pack it into the high-level elements, or where to unpack it. Sorry, Alex.
Yeah, I would say ideally you would just relate to that software via some persistent identifier, and then in the software metadata you will have this license information.
Not only for the software, but also for the metadata and the metadata and the data related data sets.
Okay.
If you are reusing data sets, you mean, Rainer? Yeah.
Yes.
Yeah.
But again, then you would reference these related datasets via its PID, and then it hopefully has licensing information in that PID metadata.
This is exactly the idea of the fair digital objects, where in the PID information record are the required information interlinked. Yeah.
So in the ideal world, it would not be repeated in a description of this data set. It would be with the data set that was used.
Because from the perspective of somebody who's coming to use the the current data set, it's the licenses that are attached to that data set that they need to worry about, not so much the licenses that were attached to the data sets that were used to create it. Because somebody else will have done the work on the legal interoperability of it. And yeah, if they are interested in that, then they can trace back from the metadata that says the third-party data that was used as input. Yeah, and work it out from there.
Christian added some information in the chat. It says there is a W3C prof to describe in detail the relationship between the steps of processing.
There is indeed, yes.
Yep.
And not only the steps, but also the input and output are also described. And we use it as, we begin to use it more and more in the climate research field. But I know that in some other scientific domains, they are using it a lot. But we have standard tools to work with that. So it's quite useful because you already have all the tools to generate and analyze those kind of output.
All right. Great. Yeah.
Perhaps we are talking about two types of data sets here. One is a data set that was formed by combining some other data sets through a computational process, perhaps. And the other one would be a pure result of measurements, which you do in the physical space. Would perhaps these two be somehow different in their metadata descriptions?
I would say that for the provenance, for example, if you have measurements, I think most of the time you don't have the really raw measurements. You still have some processing involved between the raw measurements and the kind of product you use. It can be calibration or processing to other units or things like that. But of course, in some fields, I agree that sometimes you do have access to the raw data itself. So most of the time, I think some kind of processing is applied.
But the raw data is somehow the most valuable one. You can always process again, but you can't, or perhaps in most cases you can process again, but you can't regenerate the raw data.
Right, that's very important. And sorry, the use case of like astronomy, because you, especially for space data, you collect that raw data once, and you know, and it's precious because it's a unique one-time, you know, you take this $1 billion instrument and point it in the sky. So there's so many complex steps leading up to collection of even the raw data that you can go back and do some engineering, refactoring of engineering configurations that led to the generation of even the raw data. So, you know, optical paths or, you know, detector characterization. So it's there's things that occur after the fact, even to the raw data. So I guess it really depends on the domain, you know, the application.
Yeah, that is what I was thinking when I asked the question. Is this dependent on the type of workflow of
It
the
is.
experiment you run, for example? So then
Yeah.
you have many possibilities of relevant terms within provenance, I think.
Of course, a huge discussion on what you mean by raw.
Right.
By raw, yeah.
Yes.
There's a lot of raw
because
data that's
every
useless.
data
Yeah.
item that you have is processed in a way, at least in the sensor. And
sure.
All right, we have 1 minute left to end the session, actually. This was a quite fun exercise. I'm still intrigued about the schema term, to be honest. I don't think I understand it very well. So maybe that is something we could discuss another time as well. But thank you very much to everybody for the contribution. I hope, Alex, this was useful. Do you have any thoughts on how we could continue helping out? Now we know that provenance is something that Gretchen would like to look into with us in the interest group, so we could continue there. But if there is any way you think that the people that joined today can continue contributing, would you like to say something?
Yes, absolutely. Now, I think somewhere here we should have the link to
there. No, it's in the other one. It's in the breakout session. Yeah.
There we go. So this link down here, it's also available from the metadata interest group page on the RDA website. So it should be fairly easy to find. But that gives you the. I'm trying to go up to the top and select that tab, and Zoom is defeating me. But that is the Google Drive, which has the documents in it where we have been discussing and unpacking these elements. So if you have some things that you want to contribute, please do go into this drive, open up the respective document and start typing away and give us the feedback. And yes, we will over the course of the next months try and transform what you've given us into some actual tangible results. So that'd be great.
Perfect. Thank you very much, Alex. And Matthias and Mark, thank you also for your presentation. I think maybe next year we could have another presentation in our online series seminars to see the progress of your platform. That would be very nice. We are looking forward to know more about it. All right. Thank you very much, everybody, for joining. I think it was a very nice discussion. And our session for the interest group RDM in engineering is tomorrow at 5 UTC, 5 p.m. UTC. So you are welcome to join. And Alex, you also have a session tomorrow?
Yes, that's right.
At the same time?
I think mine's at 9 UTC.
Okay.
9 p.m.
Good.
Yeah.
Great. So have a good evening or afternoon or morning, everybody. And hopefully we see each other again in another session during the RDA or later.
Yes.
Take care.
You so much.
Thank you. Thank you, Paula.
Thank you. Nice to see you, Jan.
Yes.
Bye.
Bye. Bye.
Bye.